Hi, this is David Lady again. I'm putting together a series of short little videos dissecting and talking about different pieces of the TrizIT methodology that I've published in the book Information Technology System Cookbook, which is available on Amazon.com and can be bought with one single click. If you watch the little intro PowerPoint that I put together in the little video. One of the slides had, it was the same slide, and it talks about the different patterns. The patterns, we go into the patterns in detail in the book. What I want to do is I want to just quickly talk about the first pattern. I'll put a video together talking about each of these because these are really important and they bring a lot of insights, I think, into information technology systems analysis, which is what the TrizIT technology is designed to help with. Another item that comes up sometimes when I'm discussing this is that the TrizIT methodology seems very abstract. It doesn't seem very literal. We don't mention, for example, versions of operating systems, or we don't really mention any specific piece of technology, and that's on purpose. When you look at toolkits that are designed around specific pieces of technology, one of the things that happens to those toolkits is over time, as the technology changes or becomes obsolete, so does that particular toolkit. So this is more of a universal view at a very high level. There's a 30,000 foot methodology, although it can be brought down very specifically to deal with very specific challenges. And one of the things I talk about in the book, and that I'll get to in one of these little videos, is this methodology is designed for a very particular type of problem or type of contradiction. And one of the things I outline in the book is there's 5 basic levels of problems, and this is designed for the intermediary levels where you're trying to tackle something tough, but not necessarily invent a new piece of technology or solve a new problem. So the point here, though, we're going to talk about the alpha pattern, which is the pattern of advancement in the direction of system ideals. So on this chart, that's the first one. It is the alpha pattern. It is a pattern that is predominant in information technology systems, and you'll see why here in a second. Let me go to the next slide. So the idea here is, you see there's 2 pieces to this. There's a little bit of a narration on the left-hand side, and then there's the graph. On the right-hand side, a couple things you notice about the graph. Really, we're just graphing 2 things. We're graphing costs and problems as they relate to a system. And remember, we talked about systems are part of super systems and they have subsystem components. But our focus, whenever you focus on anything, you're always focused at the system level. So systems cost money and they have problems and they deliver benefits. That's pretty much the formula. You could say that the ideality of a system, or how ideal a system is how many benefits it delivers, divided by or over as a numerator. The denominator, which would be the cost of those benefits and any associated problems that is part of the system is part of receiving those benefits. Easy examples around that are security. For example, a website that will remember all of your passwords as a benefit. If one of the problems is it's not secure and anyone can get to your passwords, then that would be a problem that would outweigh the system, making it not very ideal because the denominator in that equation is substantially larger than the numerator. In other words, there's a lot more problems with the system than there are benefits to using it. So this is the alpha pattern. What it says basically is that systems move towards the ideal. As they form, as they come together, systems come into existence to provide a benefit. Over time, it can provide that benefit at lower cost with fewer problems, or both. Think of, if you will, the first laptop computer you ever had. We used to call them luggables if you're as old as I am and you had it many, many years ago. But the laptop, initially, it was a cost to acquire the laptop. Once you then took it home and plugged it in, pretty soon you would start benefiting from it. There were certainly probably connectivity problems, battery life problems. But for a time, your use of the system, your interaction with the system, the ideality of the system to you was over on the right-hand side of this graph. So we drifted over. The benefits are outweighing the cost and the problems in using the laptop. Then over time, better laptops came out, less expensive laptops came out. Laptops came out that could do different things that your first laptop ever couldn't do. So your use of the system, or the ideality of the system, slowly drifted back to where the problems with the system, probably not the cost because the cost was an initial outlay, but the problems in, let's say, battery life of the system outweighed the benefits you were getting from it. So you elected to retire that system and buy a new laptop that had different benefits, different costs, and over time probably went through that same life cycle. So that's just one example. There's many applications of this. The idea, though, is this: it's almost like a pendulum. So as systems form, they start off on the left-hand side of this. There's a cost associated with it. They drift over to the right-hand side, the delivering benefits, and then over time, they either become part of a larger system, which is what we get to in some of the other patterns, or they lose what we call systemity. In other words, that laptop that you bought very well could be sitting in your closet unplugged. It's not part of any system. It's sitting there unused. You don't use it in your daily life. So the value of that system has reduced, and it's no longer part of the system that is your waking activities, maybe from a business standpoint or from a entertainment standpoint or whatever. So that's the idea. This first one says that systems advanced towards the ideal as they form. The closer it gets to ideal, the more benefits it delivers at a lower cost with fewer problems. So this is really the first pattern that we look for. And again, these patterns, as soon as we figure out when we're dealing with a system, say we're dealing with a corporate financial system, we figure out where we are in the life cycle of that system. We define what super systems it is part of, what its subsystem components are. And then if we discover that we're in the alpha pattern here, we look for opportunities to advance the system towards an ideal state, which includes that ideal final result that I mentioned in the other one that we'll go in a later little video here. So we attempt to maximize the benefits and reduce the costs, and those are the types of solutions that we look for when we get into our solution models later in these videos. So that's a quick introduction to the alpha pattern, and I'll do one of these for each of the upcoming patterns, and then we'll start to dive into some other elements of analysis and eventually the solution models. Thanks a lot, and I hope you find these little videos interesting.